Hello, everybody. Welcome to this meeting. Today, are we going to have the workshop Alquimétricos Homemade Building Block System Toys by Fernando Daguanno. Welcome, Fernando.
Thank you very much. How are you doing, everybody? I would like to thank Fabex Live for letting us do this workshop here. We know how difficult it is to have this kind of event online. We makers want to touch things, and it's very challenging to make an online workshop regarding making stuff. But I think we will have an opportunity to test something we have developed especially for this kind of situations. I'd like to introduce to Tatiana Tabak, who is one of the most important helpers in the project. Tatiana is in charge of design, so each instructional material you see during this workshop and in the rest of the Archimetricos websites has to do with her. So thank you very much, Tatiana, for being here and for all the work you always do. And well, I don't know if somebody has any question. I would like to say something very, very briefly in Spanish and Portuguese, because we invited people that perhaps is not talking English. So, hola a todos y a todas, aquí Fernando Daguanno de Alquimétricos. Nos encantaría que si hay alguien de la comunidad hispana que no habla inglés y necesita traducción, nos lo diga por el chat, así sabemos y les damos una mano, hacemos traducción simultânea mientras damos el workshop. Alô, alô, pessoal da comunidade lusofônica, aqui Fernando Daguanno, fundador do Arquimétricos. Estamos junto a Tatiana Tabak, que sim é brasileira, então se alguém da comunidade brasileira, portuguesa, do resto do planeta lusofônico tem dificuldade com o inglês, por favor, falem no chat, que a gente vai fazer tradução, tá bom? Muito obrigado. Então, se todo mundo acorda, vamos começar. Se todo mundo tá junto, vamos começar. Let's start. So, vamos a comenzar. Entonces, Alquimétricos, para quien no lo conoce, es un proyecto que comenzó hace 5 años. Alquimétricos is a project we started 5 years ago in Argentina, and it rapidly moved to Brazil. I live in Brazil, actually, and we developed a building block system that you can make at home using very simple tools and materials. We did that because we all know that there are lots of building block system, commercial, mainstream building block system that allow us to learn all the STEAM field, the science, technology, engineering, arts and math field while playing and having fun. But unfortunately, most of those building block system, mainstream building block system, are very expensive for most of the global south population. I'm talking about countries like Brazil. I'm talking about continents like Africa. It's very difficult for people in those countries to afford to buy that kind of toys. That's why Alquimétricos created a very affordable and open source building block system that you
Is everything okay? I can't hear anymore.
Yeah, sorry, one second. Didi, can you unmute him? Sorry, Fernando, one second. Fernando, is there a place on your video that says unmute? Didi, is there a way to click unmute on his name?
But his name is unmuted. The other one is the workspace. So I don't know if his sound is coming from the workspace or from the other one. See, there are two.
Here I am.
Fine.
Can you hear me?
Okay,
Okay.
great. Yes.
Correct.
Okay. For some
Sorry
reason,
about that.
I went mute. Where did you stop hearing?
About this theme,
Okay. I
about the
was
building
talking
blocks
about
being
the-
expensive. And
Yeah. Okay. Thank you. So, as I was saying, the STEAM field is fundamental for the 21st century education and professional life, and the world is asking us to have each time more skills and more literacy basis is each year higher. But at the same time, we have a big inequality in the world in which most of the families in the southern, in the global south, cannot afford to buy a box of, don't say any brand, but we know a lot of very good building block system. So we decided to make something affordable, something you can do with very simple tools and materials, even recycled materials. And this workshop will show a little bit about our proposal, about our system, and how you can make that at home. Can you see my screen? Is it, are you able to like maximize the Fernando workspace screen? I'm asking to the host. Can you do that?
Yes.
Is everybody seeing my workspace as the main screen? Perfect. So you will find Alquimétricos educational materials, instructional materials in our website, alquimetricos.com. Is it available in Portuguese, Spanish, and English? And we are developing new materials with new language. Italian is being launched soon, and we are always welcoming people from other countries to help us translate our contents to new languages. So in alquimetricos.com, you will find our 101 course in which you can find this kit. I will show you very fast. We have, I will share my screen now. So I will show in this video. In this Archimetricos 101 link, you will find all the first 6 units of our instructional materials, which describe the procedure to make Archimetricos at home. We also have this this PDF for download that Tatiana designed, and I really love them. And you can find all the instructions, the materials, the tools you need to start making your Archimetricos at home. Of course, this is a handcraft version of the project, and you will find that we also make use of digital fabrication tools. These templates are made out of laser cut MDF, and this is EVA rubber, also can be laser cut. In this particular case, it's not laser cut, but we make use of laser cutter for creating lots of kits. You can find online too. You can also find at our other website, which is only in Portuguese by now, which is alkibots.cc, in which you will find a more robotic-oriented set of kits and activities. So I was showing a bit of our instructional materials. Our website is showing 6 different units, from introduction to how to trace your templates, how to make your templates in case you don't have a printer. Let's remember we are targeting for the global south. A lot of people in Latin America and Africa don't own a printer, and they are lots of them are locked down right now in quarantine. So it's difficult for them to have access to some resources. So we developed a way that they can create the kits not even needing a printer. Normally, we share our templates like this. Let me show you. This is our templates. And this is our business card, which is an Archimetricos shaped piece of paper or hard paper. And this is the cheapest and simplest way we can promote ourselves, and also give people the opportunity to have the matrix source to start creating their own Archimetricos. So what we use the template for is quite obvious. We pick a material. This is EVA rubber from an old mouse pad, and this is my template, which is harder and have bigger holes than the connectors, and you just trace the shape into the material. You mark all the holes. You don't need to mark the holes in all the connectors you will make, because as we will see soon, you can stack, when making the punch hole, you can stack 2 or 3 connectors together. So this is how you like share your design to the material, and then you can start making. You can make any kind of questions and comments. I can hear, I'm reading the chat. Y si hay alguien en español o en português que necesita algum tipo de comentário, por favor, fala aí se precisa uma ajuda, tá bom? So we have traced the template into the material, and now it's just cutting it, you know, like a pair of scissors. If any of you have like made all their homework and have taken the materials that we announced in the workshop list, you can even like activate your screen or send us some photo or video, just like to see if you are going through the path in the same way that we are. I must say there's a little like learning curve in the beginning, because Archimetricos is not about being very precise. It's not being exact measure. It's not about exact measuring. It's more about relationships. The relationships that are established between the materials you get where you are in your community. That's very important to understand. We are not talking about this hole should be 2.3 millimeters. This hole should be related to your sticks. And these are bamboo sticks. Like, you can also use chopsticks from like Thai or Japanese food. You can use any kind of stick you find in your local community. Even you can use some kind of straw, or if you get any hard straw or perhaps wooden stick. I wouldn't recommend pine sticks because they are not very resistant, but it's basically about like having two kinds of materials: a connector and a beam. The sticks will do the beams, and this is EVA rubber that will do the connectors. We will be doing connectors out of different materials. So these are the tools we usually use. These are the templates. The tools I usually recommend to use in handcrafting Alquimétricos are these three tools that are a pair of scissors. These are pet nails nippers. You know, when your pet nails are very long, you should cut them, not to harm anybody or any sofa. So this is very nice tool because it's very cheap and it cuts the sticks in a very smooth way. You can cut it, even a strong stick. You just have to take care because the tip will be like it can be spring separated. So don't aim on anybody's face because it can hurt somebody. But this is a very nice tool for cutting the beams. It's a tool that even children can handle. And this is a punch hole plier. This is my laser cutter. This is the tool I use when I have no workshop. When this is something that costs like $5 or so. And in particular, this one has a leverage point. There are other ones that don't have that leverage. So this is it is a stronger tool. With the same force, I might make more. I can punch harder materials without applying so much strength with my hand. And EVA rubber is a material that it won't have problems with punching. You just have to like measure the diameter of the stick and try to use a punch that is slightly smaller in diameter than the stick. So I have stacked. Let's do two connectors, and I will just punch them. I will make this circular movement because it's the equivalent of like jigsawing a knife back and forth when you are eating meat, for example. This is the way you make less effort and have more a better result. So it's just about punching all the holes. Remember, I just traced the holes in the first one because the second one won't need marking, tracing. So here it is. You will see these scrappy buttons it will release, and these are the new connectors, and the way you use them is very specific. You just pick the tip of your stick near the tip, like if you were going to write with a pen, and you insert it in the first hole near the point. You take it the other way around and you put it through. That's it. That's the whole thing. Now this is a connection. This is a link between the connector and the stick. You make the same thing with the rest of the connectors, and you start building anything you want. It's actually a very your creativity is your limit. It's very good for teaching geometry because you can make all sorts of 2D and 3D connections. I should be punching this, but I'm quite lazy right now, so I want to show you some other things. This is the main principle for building geodesic structures, which I will be building right after, by the end of the workshop. So until now, is there any questions? I'm reading some questions. I would like to make a very short pause. What material are you using right now? Foam, EVA foam, yes. PVA foam, old mousepad, yes. This is an old mousepad. Does the size of the template matter? So this size of the template I use because it's very generic. It fits all kind of small projects, but I also use larger templates because I sometimes I need to make bigger projects. I will show you something. Let me see. There are sometimes I need to make bigger projects, which I cannot see right now. Here. That happened last year in FabLab Cuenca, in Cuenca, Spain, as part of our European roadshow. We went to Portugal, Spain, and Morocco, and we kept traveling and making all kind of workshops and residencies. That one was a very nice episode in which we built that 5 meters high 5 meter high, 7 meter in diameter geodesic domes. So for that kind of project, we use different templates because, as you can guess, you need bigger structures. This is another. Let's see the difference here. This is another scale of project, you know. So this is EVA flooring. Do you know that one for gyms and children for kindergarten flooring? They are like 1 meter by 1 meter or 5.5 meter sided squares, like puzzles you can put together. And it's 10 millimeter thick, 10 millimeter thick, and you can take almost 12 out of one foam block. So it's quite cheap, and it's very funny. This one is made out of laser cutter. We can use other kind of cutters or scissors and other punchers. Let's see other questions. Does the size of the template matter? Already said that. EVA water, the holes must be adequate to the diameter of your stick, so it's no loose. Yes, that's a very important thing. You can use thicker or thinner materials, but you should take care of the relationship between the hole and the stick. And if you use a hole that doesn't fix very well, for example, I have another size of template of connector here, that the connector is very loose because it's almost twice in diameter. But I can do something. It's a very useful trick. I use this. Let's clear this out. I use these elastic bands That's Rainbow Loom elastic bands. Sorry for the noise. You know, these elastic bands that are usually part of those crafting projects for making, like, I don't know how to say pulsera in English.
Bracelet.
Like bracelets.
Bracelet, thank you very much. So these elastic bands are very easy to use. You just take one, you insert it here in the tip, you pass it through the back, and you insert it again. And this is a very strong link. This is an exaggerated case in which we have a very, very loose stick versus hole relationship. In some cases, we will be using a bit tighter relationships, but some materials that I will show right away are not as flexible and elastic, and they don't provide much grip. So that's the way, using these elastic bands is the fastest way and safest way to create a stronger, tighter link between the connector and the sticks, the beams. So I will go through a bit more questions here. Tati, what is the tool called Fernando is using? This tool is a punch hole plier. It's a very cheap tool. It's like, I suppose it's like 100 years old. It's very, very popular among shoemakers and that kind of crafters, artisans. It's something you can get on eBay by like $5 or something if it is new. It has multiple holes. You can start on 2.5 millimeters and you will end up 4.5 or so. Some of them even show the number of the in millimeters. So it's very. I recommend that you get one of these, because in these times of no Fab Lab, no workshop availability, it's something that can like really allow you to make as many Alquimétricos as you want at home. It should be adjusted, the diameter of the hole. We have already said that.
Fernando, maybe I should comment also, because since we're in this period where maybe people can't get the tool, we also thought in the guidelines to suggest other tools that maybe are not the best ones. Like this is the best one to do it, because you can adjust the holes to the size that you want. But also you can comment on the other alternative tools that may be used.
Yeah, you can find that in the guideline. It is very well described. I can show you in a moment, but basically there's a family of tools you can use. Perhaps an owl can help you make the holes. It's something you have to be careful with, especially when working with children, you know. Here in the guideline, you can download from our website. Punch hole plier is the most recommended one, but you can also use an owl that will allow you to make like punching a piece of EVA rubber is very simple thing. You can make it with a nail. You can make it with a hot solder. It's very smelly and smoky, but you can also do it. Some of these sticks, of these chopsticks, they come, especially those from barbecue, they come with a very pointy end, so you can't use it to punch a hole in the material. I will use these chopsticks just to demonstrate how you can like actually make a hole out of like any, like I have already punched it. It is possible that the material end up breaking apart, but you must test, you know. You can do it with the point of a scissor too, but I don't recommend you use procedures that may hurt or may result in bad learning of how to use a tool by the children. So I wanted to show you a short video on how we make the templates in case you don't have a template and you don't have a printer. How do you start this activity without a template? You can draw it by hand or you can draw it in your computer, but you can also make use of this digital procedure. You just download a PDF or shape. A PDF file from our website. You take a stripe of paper, you glue it to your cell phone or tablet or screen of your computer screen, and you just trace it with using the backlight of your cell phone. You just turn off your room lights so it gets better contrast, and you will have a base traced template that you can, like, you make all the variations, all the geometries you want. This will repeat the process for each of the geometries. And then after you have already traced the paper, you should use something stronger, you know, like a material that will resist many uses and your pen can trace easily. So we will later on glue this traced paper templates into a piece of cardboard, for example, that is something thick enough and easy to cut. And then you wait until it is dry, you cut it with the scissors and you punch hole. You punch the holes on it, and that's it. You are ready to start tracing. I will show you the next video, which is focused on that process. And that's the cheapest and easiest way we found to transfer the design into a harder material that you can use to replicate the connectors. And talking about making templates, I think it's one of the most important activities when starting making Archimetricos with children. I work with children usually 6 years old and older. Like we also work a lot with teachers, and we like use this same method until like university, you know. We also make architectural project with this principle, like Geodesic Domes and tensegrity structures. So when we start the procedure, we hand the templates to the children or to the teenagers, and we tell them how to make their own template, because they can have an idea on how they can make their own making tools, you know, their own resources, and that they can replicate. And this is software, you know, this is a piece of information that you can share, you can copy in the same way you'd copy a software program. And it is very important for us to leave leave that point clear, that they can replicate, that they can make their own, and we invite them to make 2 of each, because they can have one and give one to one friend or something like that. And it's part of the core spirit of the project, to make more than one and to share, and to have in mind, this is something else. And to have in mind that this is an open source project, and that is made out of the work of like many people doing different things, and collaboration and co-creation. So, is there any other question until now before we go to the next step? Any comment? Tatiana can also add whatever you want.
No, I think I'm good.
Okay, okay.
Yeah.
So I will make a specific variation before entering some more complex project. I will make something very, something I like a lot. This is a tomato sauce box. You know, you can. It's the same material of milk boxes and shoes box, shoes box. It's like Tetra Brick or Tetra Pak, depending on your region. It can be named differently, but it's basically a piece of cardboard layered with some aluminum and plastic and print and protection. As far as I know, it's like 7 or more layers of material. I said that is we use lots of recycled materials. This is one of them. I like a lot working with this material because it's not so easy to recycle, you know, like most of the time it ends up in the trash, and it is, even for industrial recycling, it's not very easy to process. So it's very interesting to have something useful to make out of it. We also make use of other kind of materials. This is these are sachets or milk bags. They are plastic bags that are also layered. You know, it has a very it has lots of layers of different polymeric composites that end up protecting the product very well. I just like wash them in the, like I cut them open and wash them in the sink, so they end up very clear, clean and dry before working, because if not, it is very unhealthy. And if you put 2 or 3 or more together, and perhaps you should like cut them and reverse them, you know, like to put the outer, the inner part out. And I will just demonstrate this very simply. But if you take a sheet of vegetable paper and you put it in the base and in top, and you iron this with your clothing ironer, ironing, you will end up with a thicker and stronger layer of plastic, which is very useful for this kind of projects. So there are lots of ways you can recycle materials to make Alquimétricos. And as I said, I live in Brazil. I'm from Argentina. We have a very tough reality in terms of like neighborhoods in which buying EVA rubber, which is a very cheap material, is not an option. So when you can use something that is already at home, it's a way to, in some cases, democratize the access to these educational tools. So this milk box cardboard, I will make a special template for this, and I will show you how I do it. I just need a piece of cardboard, which I don't know where I put. Just a minute, please. Here it is. I have a piece of cardboard, which is also recycled, of course. And I will make something very specific. I will take this template, this hexagon template, and I will trace the same way as I trace it in the connector, but leaving one side untraced. And that's because here, that's because I will make a second one right after, right side by the first one. I will trace the holes just in one of them, thus making a double template. And this is very useful, especially when talking about this kind of material I'm showing right now, the milk box cardboard, the Tetra Pak cardboard, because depending on the product and your region, you will find that that material can be quite thin and not very it's not elastic at all. So what should we do? I will make use of my punch hole plier, the biggest hole possible. I will show you why, but I will make the holes in just one of the sides. Can you see it? I'm trying to show it to the camera. There we are. Okay, two more like that. Here it is. You have a double template, and with this double template, we'll mark double connector. Why? Because this material, as I said, is very thin, very, very thin. But at the same time, it has printer it has like in the packaging, the product, actual product communication stuff in the other side. And let's face it, we are making toys out of trash. So we don't want our children toys to look like trash. Even though they are made out of recycled materials, they don't deserve to have toys that look like rubbish. And by making a double connector, you gain two benefits, which are you will make the material stronger, and you will hide the product packaging stuff in the inner part of the connector. So when you use this kind of Tetra Pak material and other materials that have product printing on it, I really recommend using a double template, and that you make this connector like this. So now it doesn't look like you are using a product, you know? You're just hiding the inner origin of the product in the inside. I will use a hole that is as near to the, it's quite a bit like smaller than the stick. I think that will do. Let's make a test. I will try to punch hole the first one, just to make a test. Okay, so I have to make a little force here. I should use one that is a bit bigger. So let's see. I'm not seeing which size is that. I will use this other one. Okay. Let's try. Okay, now it fits. And it is very important that you make some kind of turning force, because that helps the insertion, you know. Other things you should be doing is like using piece of sanding paper that helps taking the splinters out of the cut bamboo sticks or any material sticks you have, and it makes it a bit rounder, so it's kind of easier for the insertion, you know. you can keep like looking your best relationship between your connector and your material holes. I will try this bigger because I don't want the small kids to frustrate because they cannot insert the stick. But here, what happens? The sticks is slightly, it's almost the same size, so it is very loose. But as it is flexible, when I turn it, it's a bit tighter. Not as tight as I would like. So I will use an elastic band. I will put the elastic band there. So it's a compromise between like the materials we have, the tools we have, the perfection we want in the connection. It is very important that the children don't frustrate in the process. I really recommend you try this 2 or 3 times. You make your own project before trying with children, because there's a small learning curve, and you should discover where is the working area and the failure area. Some relationship between your materials, your tooling, your sizes just won't work, and some will do. So if you try and fail in your own, and then you start activities with the children, you will understand how that can prevent the children from frustrating and finding that the system just doesn't work. And there's something about the children having to make some like force, having to like gain some precision, and this I call this finger gymnastic. You know, when I invite the children to make exercise with the rubber bands, because it is very important that they develop the ability to like handle small things and making some small and precise strong movement with the fingers. It's wired in our inner like homo habilis brains. You know, we have been developing this capacity to think with our hands, to learn to craft things. This is something we encourage everybody to try. Somebody is saying milk bags are plastic.
No, this is me.
Oh.
I was answering because Gil asked which materials were to be ironed. So
Okay.
I answered there was the milk bags, but you should be careful because they're plastic, so you have to cover them with cloth or paper.
Of course, and you have to do that in a ventilated place, because when you hit plastic, some fumes came out of it. So I recommend you do it outdoor or with a fan near you, and you use your lower ironing temperature, and you keep trying until you find the best your best fit. I recommend you research the thermofusion possibilities with home clothing ironing, because there are lots of things that can be done, mixing plastics and textiles and vegetables, and it's a very interesting process.
But Gilly thought it was that you ironed the milk-coated carton with another material. No, the milk-coated carton was used by itself, just as a double. So it's thicker?
You should experiment actually, because it has a polypropylene layer in the inner, in contact with the product. So in some way, there's a possibility to melt things, to burn, yeah, to weld things into this piece of milk cardboard. You should like experiment and research. I cannot like say much about that here today regarding Archimetricos, but it's something very interesting to do. So how are we with the time? It's 1 hour since we started. Is there any question, any comments you want to make? Somebody wants to something specific to be that we can talk about? There you have, I'm seeing Kumar. Kumar, my friend.
So it's pronounced as Dibjyoti Kumar.
I won't be learning that just today. You know that.
This is called Deep, DIP, Deep.
DIP Deep.
Yeah, Deep. Yeah.
Nearer. I will learn how to say your name, to pronounce your name. Thank you for being here. I'm very glad you made it.
Yeah.
What are you making there?
Yeah, I tried it with tire tube basically. I was just trying it with trying to see with tire tube. So maybe like we can do with plastic sheets like bottles or something. We can use maybe or those kind of stuffs also. Like we can upcycle plastic containers or like bottles, something which has a very flexible strength, and like maybe try with that. Maybe I will try.
Of course. There are lots of materials we can experiment with. I have in the beginning. I used to work with PET bottles, you know, PET bottles, but are not very easy to punch. It's a very strong layer of material that needs a lot of strength. Something I wanted to tell you is that if you stack more layers of thin materials like milk boxes, it's actually easier to punch that. You know, when you stack lots of layers and you make a punch hole, it is easier. It's counterintuitive, but it is easier to punch lots of layers at the same time than punching just one. So I recommend when using cardboard that you stack like 4 or 5, and it's faster too because you like trace just one option and you punch hole all together. Another interesting thing about these Alquimétricos connectors and the fact that they are made out of flexible materials is that what defined a close structure is that you have perhaps a triangle like this, and that makes it a fixed structure. But at the same time, you are making use of a flexible connector that allows mobility, and that's very interesting because this, which is going in the path for a pyramid, you know, like this, this has movement and has a lot of possibilities. You can like make some kind of crocodile or perhaps a bird beak, you know, and you can put eyes on it, and you can like use it for storytelling, and you can invite children to discover which creatures they can build out of it. And it won't be covered today, but Archimetricos don't end just in the structural stuff. You can make actual animated or interactive project. This is a piece of electronics I like a lot, which is, this is a servo motor, which I use connected with some kind of, this is an adapter, some kind of ways we are finding to make Archimetricos more compatible with electronic components, which are like laser cut bits of MDF. They are very cheap to do. They are very simple. They are not available in our website yet, but they will be soon. So with just one of these, you can like connect a servo motor, and you can use perhaps just an elastic band to fix it. It is not the best way, but it's very, for prototyping and for testing, it's very agile, and it is very cheap, and the children don't need to use like a hot glue gun or things like that. So you can test it just by like stretching an elastic band into it. So with this adapter, this accessory, you can like connect a stick to a servo motor and then into an Archimetricos structure. So this is a Servomotor Tester, which is a very cheap, it's a $1 component. I have a battery charger here. And the interesting part about this is that you can like control in a very intuitive way without using any Arduino or programming. You don't need a computer, you don't need any kind of coding. You should also get into coding, but younger kids perhaps can experiment with this without having the need to know how to read or anything. You can also use like Scratch, the non, how do you call the smaller, the tablet version of Scratch that you don't need to read. I would like you to ask you which kind of structure you want to build next. I have some materials. I have some ready pieces. Obviously, Alquimétricos is very good for geodesic, platonic solids. You know, this is a pyramid, a tetrahedron, a double-edged tetrahedron, which is not very difficult to do. You just take a hexagon and you make use of 2 sticks for each edge, and then you put everything together like we did with the simple tetrahedron, and it is quite an interesting shape. We can also make all the family of platonic structures. Let's make a cube. I would like to make a cube because it is very nice what we can do with an Alquimétricos cube. Let's do this. For a cube, we need 8 connectors. We have, let me be lazy and take some that I have already made.
Maybe I'm gonna, because some people are leaving, I think because of the time, because we've been over an hour, even though it was a longer workshop. So before we do the cube, I would like to comment that we have a crowdfunding campaign going on. I'm gonna post the link here on the chat. And we are trying to get all this material done and also donate to communities in Brazil which may really give a good use to this product, because it's an easier and cheaper way to, you know, to engage with building blocks and a lot of maker culture, and also, you know, Steam and all the contents that will be available. So I'm gonna post it here. So if anyone has a interest in getting on the campaign, we'll be very excited to do that.
Thank you. And it's very interesting that you also take into account that the project is completely open source, and we are an open community, an international collective of multidisciplinary community of makers, artists, teachers, informal educators, translators. We need help for making this available for children in different places in the world. So all the help you can give, like donations of your resources, as well as perhaps if you can help translating or creating new projects, is all welcome. So let's finish doing this last simple project, which is the cube. As we all know, cube is a 6-faced regular polyhedra. I like jumping using one line of holes and leaving one because it's more symmetric. And well, we will start making a simple square at the beginning. I'll close this here. Sorry, I don't have all the connectors in the same color and finishing. I said I was lazy. I was making some of them, and here we are. See if we make the same size. Okay. Okay. So I'm doing the second square right now. This connector, this gray connector, and I use it right now, it's made out of publicity banner. That vinyl plastic textile that is printed in one face. It's also very difficult to recycle material. It's I don't recommend you laser cut it because it's toxic actually. But you can. The fun thing is that you can, if you have one, you can cut it with how do you call it? A plotter. Yeah, a vinyl plotter. Those that are usually used for lettering. You know, vinyl adhesive vinyl lettering. It's a very interesting process because it's completely different way to digitally produce Archimetricos, and it's very effective actually. And you can make lots of them. You can make it double. I recommend you use the double template design. In our, if you are going to use that vinyl cutter procedure, we can share some videos of the process, and the designs are on our websites. You can download them. So here's the cube. There's nothing very charming about the cube. Everybody knows the cube, but this particular cube, as it has flexible connectors, has the possibility to collapse. And it's a very interesting phenomenon that you can like experiment with the children, and how many possibilities are there inside of the cube, you know? How many, let's see if we can collapse it completely into a single beam. You know, in terms of dimension, you have a three-dimensional a polyhedra, a three-dimensional body that turns into a bidimensional body that turns into a single-dimensional-ish body, and it comes back. I recommend you do the elastic band trick just to keep it all connected. But it's very funny to play with, and you can also twist it. Actually, let me twist it. You can also like make different experiments with it.
Oh, Fernando.
Tell me.
Yeah. So is the gray one a flex material, like for that is used for printing and like for media, all those kind of thing?
Yeah,
is it a
you know
flex?
those. It is flexible. It's the same as this one.
No, is it the material used for printing purposes, like for like banners and all this?
Yeah, it's marketing, it's publicity purposes. It is for banners, printed banners. Normally, it's like an inkjet technology printing, and it is very difficult to recycle. It's PVC mainly, so industry don't know what to do with it actually, and it is very abundant because well we live in a publicity world, so it is very used, and printers, the kind of producers that make this kind of thing usually have lots of scrap that is even cleaner than the one that is exposed in the street or has been used. So as I work a lot with the recycle, I usually build a relationship with the producer, so I get quality scrap. So does anybody want to make any question, to make any kind of comments? I'd like to hear your here I'm looking for Tati's sharing our crowdfunding campaign. I'd like to thank once again Didi, Tati, and the rest of the FabX staff that made this possible. We are very happy to be being part of the project, of the exhibition and the online event. And Archimetricos.com is our site. You can like send us your comments. I would like to share the the collaborators call, which is collaborators call Alquimétricos, which is the way we can like build our community. In that link, you will find our form to be part of the community. And well, thank you very much for being here. I will be like 5 more minutes if somebody wants to make any kind of comment or question or anything. Thank you very much.
Thanks so much. You have a question?
Yeah. So Fernando, so like I think we are talking, like we are already connecting over the platform over there. We are talking regarding the contribution. So so the problem that we face over here is that we in my place, like basically in the northeast, in Assam alone, we have more than like 15 like vernacular languages, like kids mostly speak. They don't speak like, we have Assamese, like which is spoken like when you are in school, but when you are at home, like kids normally like talk in their mother language. And we have a lot of tribes over here. So like 15, like more than 15 different communities, like who speak different dialects are over here. And like so what I was thinking, like maybe we can like take this project and like do like put in our flavor into this, and like basically like have like different translation for this thing, and like see what are the materials available, more locally available materials, and like maybe like maybe package this kind of these toys, and like maybe like publish like more templates, or like maybe publish uh, how to DIY like materials, and like maybe like circulate it in our region like more specifically. So how do you go about it, and like what's how can you do it?
That would be amazing. Really, we have released our OERs, our instructional materials, completely open with Creative Commons by licensing model. You can even use Archimetricos commercially without giving us any kind of royalty. That's something we have thought a lot about, and we have decided that it's better for the project to to grow even if we lose control of it. So we can also share the editable materials that you can use to translate it and to hack them and to remix them and make your own variations. So we are already in touch. I think we should like talk a bit further about that, and I would love to have these materials translated to um, your languages, because that would be a huge size of the population that can take advantage of the project. That would be amazing, really.
That will be great. So also like I have not explored like more into the like more of the electronics that you have implemented, like, but we have a plan, like so we started like we are like basically like our team was editing on like developing a basically a kit which is for our in terms of our currency, it will be like 1,000 rupees, like within 1,000 rupees a programmable robot. So that was the idea that we're going with, so that like at least a school can have at least a bunch, at least like 10 kids, which can be like circulated in different classrooms. So like I saw the like template that you were using, like which was the breakable one, that can be broken up, and like you can make like patterns out of it, like maybe structures out of it. And also like I just saw I saw the
This
Arduino.
one.
Yeah, this one. Yeah. So I saw your Arduino based like platform. So what we are trying to see, like we also want to basically implement the language, like basically the drag and drop block programming sort of a thing, to introduce them to programming and not directly go into the language part of it, like just basically the logic more focusing, making them more focus on the logic part of the program. Yeah, logic part of the program. And so that is also one thing that we're seeing, like how do we make easy to use, like maybe an app, or like an easy to use program which where they can just drag and drop in their own language. So the idea was like to again like uh, do something so that like they use the basic words as of the first step should be in their own vernacular language, then they slowly graduate into like the common languages of maybe whatever the software can provide. But the starting point, you want to like put them, like make them as much comfortable as possible for the transition phase in the technology process, because like it's like uh so not much have been over like has happened over here, like uh, so I graduated in 2013. I didn't have like when I completed my school in like my schooling in 2007. I didn't have access to all this kind of thing. So like when we graduated like in 2013, I completed my mechanical engineering mechanical engineering. So at that point, till that point, like in this college period, I had some access to electronics and robotics, and I got more interested into making stuff. But then like when we go again to the field and see like these people, the kids, like where they don't have access to proper infrastructure, so this kind of materials can actually have some like sort of a like good impact in their lives. So yeah, like so that's why like I got like more interested into you. The choice of material was very interesting. Like that's what I was trying to say. The choice of material that you used for at least the basic geometry, or like making the understanding shapes, or at least make a toy for themselves. So that was a very like fun part of it. So we did more with electronic part, like maybe a simple motor, take a motor out of your trash toy and like put it like those art bots, brush bots, those kind of more into like those kind of activities we are like basically doing. So yeah, so this will be a very great addition, and also I guess we can do some like good work over here.
Of course, of course. I think we have a lot of in common. We are targeting more or less the same kind of audience, and we are dealing with the same kind of challenges. So I really think we should keep talking and contributing with each other's project. As you may see, we have started linking Alquimétricos with electronics and robotics, but we haven't developed so many layers upon that. So we need to partner with other collectives that has that part more developed, so we can deliver and receive help. So let's keep in touch. Thank you very much.
Yeah, so we'll be contact. Thank you so much for this session, man.
Thank to
Really
you for being here,
yeah.
for sharing, and for already making your Alquimétricos live.
So yeah, this is it. So it is
Thank you.
more like I just tried to punch it. I didn't actually punch hole. I had this like big puncher, like, but the thickness
So that's
of it was
one way to do it. Yeah,
That's
yeah.
great.
yeah.
Yeah,
It's
that's just
another
So,
way
but
to
like
do it.
the thickness was like more like the tube that I was using, it was more is more thick. So like I couldn't like mainly figure. So I just used I used this like I poke holes through the tip of this and like just screwed it through it.
Then
Yeah,
I will want for you to send me some detailed pics on
yeah,
on the
sure, sure.
material and everything. So is there any other question or comment or anything we can answer? Is right the moment right now? Anybody else?